All right, the moment you have all been waiting for has finally arrived. We are going to look at solving quadratic equations by using the quadratic formula. Now, this is something that you should have seen before in Algebra 1 and in geometry, but the nice thing about the quadratic formula is that even though it's this big long thing that you do need to memorize, it is usable for any quadratic function, just like the completing the square method is, whereas factoring can only be used on certain types of problems. Quadratic formula lets us solve any problem. I am not going to sing it to you here on the video. If you really want to hear the song, I can include a link to it, but I am not going to sing to you here. I am sorry. So, solve using the quadratic, that should say formula. Typos. All right. So to solve using the quadratic formula, we need to have everything on the same side. So I'm going to, I like having a positive x squared. So I'm going to move this 4 over. And we get 3x squared minus x minus 4 equals 0. I'm going to label my a, b, and c values since I have to use those a lot. All right, so then the quadratic formula says to do x equals negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Now, notice that I put all of my a, b, and c values in parentheses. I did this because I want us to see that I'm actually substituting in -1 right here. When it says negative b, it doesn't mean that this number is always going to be negative. That negative in a formula just always means change the sign. So I wrote it as negative and then times -1 because I want to make sure that we're understanding what that negative means. So let's do a little simplification here. First of all, -1 would just mean 1. Now, under the square root, I'm going to have -1 squared, which is a positive 1. And then what a lot of people forget is that this negative right here goes with the 4. So I'm going to do -4 times 3, which is -12. -12 times -4, which is positive 48. And then that all goes over 2 times 3, which is 6. So I've got x equals 1 plus or minus square root of 49 over 6. And then I know that the square root of 49 is 7. So I'd get x equals 1 plus or minus square root, or sorry, not square root. Square root is gone. And plus or minus 7 over 6. Now, this is not our final answer, but when the square root gives us a positive whole number, like 7, not an I, it doesn't have a simplified radical, I'm going to write this 2 times. I'm going to write it as x equals 1 plus 7 over 6. And I'm going to write it as x equals 1 minus 7 over 6. So I'm going to get 8 over 6, which is 4/3. And I'm going to get -6 over 6, which is -1. So my 2 answers would be x equals positive 4/3 and -1. Yay, quadratic formula. All right, let's do another one. I need everything on the same side, and it doesn't matter if your a is positive or negative, but like I said, I like to have it be positive, so in this case, I'm going to move the 2x squared to the other side. Okay, now my a is 2, my b is 4, and my c is 3. So I'm going to get x equals negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. All right, a little simplifying. I'd get -4 plus or minus. What do you get when you simplify what's under the radical? I got 16 minus 8 times 3, which is 24, which would give me square root of negative 8. Now, in previous years, you would have said negative 8 means there's no solution, and you're right, there's no real solution. But I can simplify square root of 8 to be 4 and 2, 2 and 2. So I'm going to rewrite this as x equals negative 4 plus or minus 2, and then because of the negative, an I is also going to go outside of the radical, and then a 2 stays inside. This 2 right here comes from the pair. This 2 comes from the one that did not have a pair. All right, all of that is over 4. Now, here's the downside of, not downside, but the thing that I think most people forget with the quadratic formula. We do need to always look and see if we can simplify, if there's a radical left. So what we're looking at when we're simplifying is we're looking at this number, and this number. We don't care about the number under the radical as long as it has been simplified, like we didn't leave it square root of 8, we are good. So I can divide all of those by 2. And when I do that, I get 2, 1, and 2. So my final answer will be x equals negative 2 plus or minus I radical 2 all over 2. And since over here we had to write it twice because this number here was a whole number. When we took the square root of 49, we got a whole number. Whereas over here, we had a radical left. So you can just leave your answer like this. You don't have to write it 2 times of x equals negative 2 plus I radical 2 over 2 and x equals negative 2 minus I radical 2 over 2. Just write it like that. All right, so that's all stuff you've seen before, but this might be something new. So discriminant is basically the stuff that's under the square root. It looks like this and all that. But the discriminant tells us a lot about a quadratic equation, specifically how many and what type of solutions the equation is going to have. So if b squared minus 4ac is greater than 0, there are 2 real solutions. Or in other words, there are 2 x-intercepts. What does this mean? What does it mean for us to say b squared minus 4ac is greater than 0? It means that the b squared minus 4ac is positive. If b squared minus 4ac is equal to 0, then there's only one real solution. That was pretty straightforward. It's just if the number under the radical is equal to 0. So there's only one x-intercept. That would have been like, that would, graphically speaking, that would look like this. Oops, that's still my highlighter. It would look like this, where you graph it, and it just touches the x-axis at one point. Up here, it's looking more like whoop, and it crosses at 2 points. And then finally, if b squared minus 4ac is less than 0, what does that mean? It means if b squared minus 4ac is negative. Gracious sakes. Okay, there we go. If b squared minus 4ac is negative, then that means that there are 2 imaginary solutions. And if we graph it, it would look something like this, where the parabola never crosses the x-axis. Our answer would look like this. This would be a case where there were 2 imaginary solutions. So for these problems, all we're going to do is determine the type and number of solutions. So basically, all we're looking for is this piece right here. So my a value is 1, b is 6, and c is 9. So b squared minus 4ac. 36 minus 4 times 1 times 9 is 36. This would be 0, so that means that there is one real solution. And that's all we're going to do with this. I just want you to see before tomorrow's lesson that the discriminant is going to be very helpful. So there's one real solution. Here, a is equal to 1, b is equal to 6, c is equal to 10. So I get b squared minus 4 times a times c. That's a 10. Sorry, that looks kind of like a 16. There we go. This would give me 36 minus 40, which is negative 4. So since it's a negative number, it means that there are two imaginary solutions. All right, so that's what we're looking at with the quadratic formula. Hopefully this was a good kind of memory jog for you. If you have any questions or concerns, let me know, and I would be happy to clarify anything that I did not already make clear.